Okay, so this is going to be a nice short video on how to differentiate tan. Not only the result, which actually last year used to be given, I think, suspect you'll be given it this year, but also if it asked you to show it, this is how you do it. We'll be using the quotient rule. So if you don't fully understand what the quotient rule is, you need to look at the previous video that I made about the quotient rule. Okay? Formula is given over here. So if you've got a quotient, which is flash word for a fraction, you can differentiate it by breaking it into two parts, u and v. The top part u, the bottom part v. So here we've got tan x. We know that tan x equals sine x over cos x. So u is sine x and v is cos x. And the formula for the differential is u dashed v minus v dashed u over v squared. Now dash just means differential. I think that's something I probably should have said in the actual teaching videos. I'll probably be clear in context, but f of x and f dashed of x and all the rest of it, but just in case anyone got confused by it. So if u is sine x, u dashed is cos x, and if v is cos x, v dashed is minus sine x. Now, I've sort of taught this without explaining why those are true. I taught those in class. You may have forgotten them, and that's fair enough if you have. Well, I'm just telling you these things now. They will be proved, but we don't have enough mathematics to do it yet. If you want to charge on ahead, look up addition formulas, because that's what you need to do, and then we'll prove them from first principles using the limit notation. So it's a fair bit of work to get there. We will get there, obviously. It's part of the A2 course, second year course. So don't stress if you kind of think, where the hell did you differentiate sine and get cos? Why is it true? I haven't proved it to you yet, but I will. Okay, now I've got the u and the u dash and the v and the v dashed. I plug them into that formula. And we get dy dx is cos squared x minus sine squared x, which gives you plus, obviously, all over cos squared x. Okay? And you can prove that to yourself by doing it. But sine squared plus cos squared is still 1. That's still true from last year. So we've got 1 over cos squared x, which is just sec squared x, because 1 over cos is sec. We did that in one of the other previous videos. So as you can see, all of these videos are starting to link together now. Alright? So that's your final answer. Differential of tan is sec squared x. You can generally just quote that, but if they ask you to prove it, now you can.